Hello students and friends, welcome to my YouTube channel. Today I am going to solve another Fourier series questions. Before also I uploaded already Fourier series problems and some basic concept also I discussed. So I taken another questions. What is the given function fx equal to 1 plus x square, 1 plus x square in terms of minus pi to plus pi. And also there are some deduce the Fourier series. So this we have to prove also. So already you know the Fourier series formula fx equal to a0 by 2, n is equal to 1 to an cos nx, n is equal to 1, bn sin nx. This is the expression of the Fourier series. So if a0, an, bn, these are called the Fourier coefficient, Fourier series coefficient a0, an, bn. If we will find a0, an, bn, we will substitute, we will get the answer. So that only we have to take care. So before this we will see these functions, given functions even or odd. So we will check first. How we will check the first? Minus fx equal to, if will come fx, this function is known as even function. If minus fx is equal to minus fx, that is called odd function. So you substitute here, what will come? 1 minus x plus x square is neither coming fx nor coming minus fx. That means this is neither even nor odd. So then all three Fourier coefficients we have to find out. Suppose some functions, given some functions will be even, then bn will be 0. So this bn term will not be there. So a0 by 2, an, this only we have to find out. a0 and an will find the even function solutions will get. If function is odd, then two Fourier coefficient, a0 and an will not be there. So only this part, fx equal to this part, we will write. So for this bn only we have to calculate. Once we will calculate the bn, we will get the solutions. So that will be the, if the questions will be even or odd. Now this is neither even nor odd. So now we will solve these questions. All three Fourier coefficients we have to find out. Okay, this is the formula I wrote here. U v integration, first function, second functions, u v1 minus u dash v2 plus u double dash v3, where u is differentiation and v is integration. Okay, that once we will solve the questions, you will see these things. So now we will start the problem. So this is the functions of the Fourier series, where a0 equal to, you have to write fx equal to this, where a0 equal to a0 is equal to 1 by pi minus pi by pi fx dx. This is the a0 formula. Then what is fx? This fx will substitute here. So 1 by pi minus pi to pi fx now 1 plus x square dx. This we got. Now we have to integrate and we'll apply the limit. So what will be the integrations here? 1 by pi, integration directly, 1 into x. You can write here 1 dx. Okay, right. Okay, you see here 1 dx plus x dx plus x square dx. That is called linear form. So then we'll differentiate dx means x plus x dx, x square by 2 plus x cube by 3. This is the integration. This is the integrations for this term. Limit will be minus pi to pi. Upper limit pi, lower limit minus pi. So if this you can write also like this, or directly you can integrate 1 dx, x square dx. So we got the integration. Now we'll apply the limit. So now see also this, suppose a and b, some function will be fx. So how we'll apply the limit? So we can write fb minus fa. What is this fb minus fa? Upper limit minus lower limit. This is the concept behind that, applying the limit. Okay. So now what we'll do here? We'll apply first lower limit as it is, you write. What is the upper limit first? 1 by pi. So pi plus pi square by 2 plus pi cube by 3 minus lower limit. See lower limit what is? Minus pi. So minus pi x square means difference will not be there because whole square na minus will become plus, cube na it will come minus pi cube by 3, minus pi cube by 3. Okay, so this will be the, this apply the upper limit and lower limit, upper limit or lower limit. Okay, now one steps you write 1 by pi add, so or open the bracket, what is pi plus pi square by 2 plus pi cube by 3 minus minus plus pi minus pi square by 2 plus pi cube by 3. Now anything it getting cancelled? Yes, pi square term getting cancelled. 2 pi, so 1 by pi 2 pi plus 2 pi cube by 3 coming. What is coming? A0. If you want to reduce, also reduce that. How will reduce here? 2 pi take common. So 2 pi will take common. Then what will be there? 1 plus pi square by 3. 1 plus pi square by 3. So pi get cancelled. Now we'll write finally A0 by 2 is equal to, this is called A0. What is A0 got? 2, 1 plus pi square by 3, this is called A0. Now A0 by 2 directly we are converting na, that will substitute directly there. So A0 by 2 means nothing but what is? 2 will get cancelled, 1 plus pi square by 3, 1 plus pi square by 3, A0 by 2. Because 2 given na, 2 will get cancelled. So this will come, this is called A0. A0 equal to A0 by 2, this 2 being here, so A0 by 2. Directly this value will substitute in first Fourier coefficient. Okay. Now we'll go the another constant, what is? Bn, An. So what is An here? Okay, right here. An equal to 1 by pi minus pi to pi fx cos nx dx. An cos nx dx, Bn na sin nx dx. So what is there here? 1 by pi minus pi to pi 1 plus x square, given now 1 plus x plus fx, then cos nx dx. This is the, this we have to integrate. So here having two terms u and v, here having two terms u and v. So we'll write here how to calculate this. So u, assume u is equal to, assume here u is equal to 1 plus x square and v is equal to cos nx. Why we assume this is u? One format is there like islet. If you write here I-L-A-T-E, islet. Always integrations will do, no? First functions will be inverse, then logarithmic, algebraic, trigonometric, exponential. So here having algebraic, trigonometric. So first function algebraic, then trigonometric, one concept. Another concept, if you will differentiate, see here, how the linear formula is there, u v1 minus u dash v2 is going on. Suppose u will become 0, then only we can stop the series. Otherwise, suppose integrations you will go v1, v2, it will continuously, it will come sin cos, it will come. So another, now you take like this terms u or first function, that after some of steps it get 0. So you see here how you will get 0. U dash equal to 0 plus 1 plus 2x. So 1 plus 2x nothing but u dash. U double dash is nothing but 0 plus 2 equal to 2. U triple dash equal to 0. Coming now 0. If we will take this u now, it will never come 0. Or this is the function first, which is first, that will take first terms. I let inverse, logarithmic, algebraic, trigonometric, exponential. That is the concept. Okay. Now v1. What is v1 here? Cos differentiation sin nx by n. V2 sine integration, because V is integration, V integration. So minus cos nx by n square. What is V3? Minus sine cos integration sine nx by n cube. Now we'll substitute here. So now this part I will rub it here. This part I will rub it. This is the problem. Pi square by 6. This is the problem. A0 I am going to rub it here. A0 I am going to rub it here. Now see, A0 by 2. You write here. A0 by 2 is equal to 1 plus pi square by 3. We have to substitute now. So this also now we'll rub it now. A0 by 2 I wrote. Now this is the function u and v. We'll write u and v this format. So that implies what will be this uv? First function is u. So 1 by pi, take 1 by pi u. What is u? 1 plus x square. 1 plus x square. U v1 sine nx by n. Formula minus u dash plus v2 minus. So finally it will come plus. So 1 plus 2x v2 cos nx by n square minus formula plus, but here minus, here plus 2. Due to this minus it will become minus sine nx by n cube minus pi to pi. Apply the limit. So this we got the uv integrations. Always these terms carefully you do this like and substitute this. Now apply the limit. Now see where the sine will be there. Sine nx always will become 0. So this makes the 0. So this term will be 0. Here sine also term will be 0. So what is there? This term. So write first this term separately. 1 plus 2x cos nx by n square. Very carefully all the steps you have to write, because any one minus plus mistakes will come, problems will get wrong. Now upper limit, lower limit apply. So 1 by pi, first upper limit. What is upper limit? Pi. So write 1 plus 2 pi cos n pi by n square over. Now minus lower limit 1 plus 2 pi. So 1 plus 2 pi, because minus is there, so 1 minus 2 pi. 1 2 pi minus over, then what is there? Cos n pi by n square. Because negative is there, minus cos minus theta is equal to, it becomes my cos theta only. Cos minus theta is equal to cos theta. How? See here, 4 coordinate is there. This suppose it started from 90, 180, 360, 270, 360. Minus theta coming, this will come this side. So this side cos will be positive. How? All sine 10 cos. So here whatever will become minus, so it will come plus cos theta only. Okay, this big concept is there, like sine 90 minus theta, sine 180 minus theta. Based on this only we can find out. So some video I will give this also. Okay. So now this we know now. Close the bracket. Now just solve it. 1 by pi cos, this terms take common. So what will be there? 1 plus 2 pi minus 1 plus 2 pi. 1 plus 2 pi, this minus, this will come plus 2 pi, cos, take common, cos n pi by n square. I taken this common, so 1 plus 2 pi and minus 1 plus 2 pi. So this get cancelled. So what is there here? 4 pi. 4 pi, this pi you write here pi, and cos n pi na minus 1 power n by n square. So this get cancelled. So what is getting? 4 minus 1 power n by n square. What is getting this one? an. What is an getting? This one only. So write somewhere an is equal to, because once I'll write na, should not be any mistakes. Minus 1 by n square. What is this one? an. 4 minus 1 power n by n square. This is called an. Okay. So we'll check once. A0 is correct. An will be A0 an. No, an will be correct only. So this is the A0. Okay, A1 we got 4 minus 1 a square. So I wrote here 4 minus 1 power n square. Now we have to find out the bn. So we have to calculate bn. So now what we'll do? This part will rub it. So this an I wrote here. Or this part again you write, because Fourier series problems will be very long problem. Very carefully you have to calculate. Very carefully you have to calculate. So what will we write here? Bn is equal to, again, another Fourier coefficient. Same method, 1 by pi minus pi to pi fx. Here will come sine nx dx. An cos nx dx. So what is the fx here? 1 plus x square. Here sine nx dx minus pi to pi. Now look here, u is this same, v is changes. Now this part will rub it. And we'll write here v. What is v? V dash. Because u will be same. So write here v equal to sine nx. v1 is equal to minus cos nx by n. v2 is equal to nothing but this, minus will be there, sine nx by n square, because one more n will come. Sine divide by n, again one more n. v3 equal to minus minus plus, because sine integration itself minus, this minus minus plus, cos nx by n square. So this we wrote now. Now what we'll do? We'll substitute there. This is u, this is v. This is the format we'll substitute. So take here, very carefully write. Take the bracket. What is u? U is 1 plus x square. What is u? v1 minus. So write here minus. What is this one? Cos nx by n. Formula minus. This plus 1 plus 2x. Then what is v2? U dash v2, but minus. So this will become plus. What will write here? Sine nx by n square. Formula will be plus. Here will be plus. So this is 2. 2 into cos nx by n square. So problems, see the problems looks very long. Suppose you are following this like these steps and just substitute plus minus carefully. Problem will be 2 page, 2.5 page. But if you will go by process, it will be simple only. But you need practice. Once or twice you have to practice. So you can solve any Fourier series formula. Okay. But you have to start the problem, beginning until end you watch. Then only you will understand. Okay. So okay. Now we'll apply the limit. So before this, any sine terms is there? Yes, sine term is there. So sine terms will come 0 only due to sine n pi is equal to 0. Okay. Now what is there? You write first 1 by pi. If you will minus pi, you will substitute here. So this term is minus. Okay. 1 plus pi square cos n pi by n plus 2 cos n pi by n square. This is upper limit. What will the lower limit? This you lower limit apply again minus here. Lower limit will be minus. What is there? Here already minus is there. So minus is there now, it will come plus only. So this you write plus. Already Okay, now this you write here minus, and here will be upper limit minus, no? So this will be, just 1 minute. So this already this is minus, so it will come plus only here. This part will come plus, but this another part will come minus. Due to this, it minus, and this minus formula what is? A to B fx is equal to fb minus fa. So due to this minus it become plus. So write 1 plus pi square cos nx by n, but this will come minus. This will come minus because this minus is there, no? Due to this minus, this got plus, but this will be, what is there? 2 cos n pi by n square. Now this we got. So this will get cancelled. Which one? This 2 will get, this and this will get cancelled. So what is remains here? This and this part. This and this take common. It will be easy for us. So this minus, no? So all will be minus. Minus 1 minus pi square. See, all I open the bracket, all minus. Now this you come plus 1. Oh, this is minus pi, no? So x, na, this will come minus pi here. Why? Because substituting minus pi, 1 minus pi, this is square, na, it will come square only. So minus pi plus pi square, and take the common cos n pi by n is, yes, n pi by n common. So look here, x 1, na, because wherever x is there will substitute the pi. So 1 minus pi, correct. Now anything get cancelled, 1 get cancelled, pi square get cancelled. So you are getting here 1 by pi as it is outside, minus 2 pi into cos n pi minus 1 power n by n. We are getting this. So then this pi and this pi get cancelled. So what is happening here? 2 by n minus 1 is there, and minus 1 power n is there. So minus 1 power 1 and minus 1 power n. So base same, power can add. So you can write minus 1 power n plus 1. Minus power 1 we can write, minus 1 power n already there, base same, power can add. So these expressions we can write, 2 by n minus 1 power n minus 1. What is this one? bn. What is this is? bn. So now we'll write the expressions, okay? So this we got the bn we got. So 2 by n minus 1 power n plus 1 bn we got. Now we'll write in the expression. This fx is there, no? So now we'll write here expressions. We'll write fx, that is called Fourier series. If the last only find the solve this, na, this is the answer now is getting. What is fx equal to a0 by 2 directly 1 plus pi square by 3 plus summation n is equal to 1 to infinity an. Where is the an I wrote here? 4 minus 1 power n by n square plus here cos nx plus summation n is equal to 1 to infinity bn 2 by n minus 1 power n plus 1, then sine nx. This we got the Fourier series we got. Now they are asking deduce that. Deduce that, a very simple method is there. Lot of books, lot of things will be there. What you do now? Substitute both limit. Now these things I will rub it. Now concentrate here. How to deduce that? So the given limit minus pi to pi. So first substitute x equal to minus pi. Okay. X equal to minus pi, in the equations number give 1. Okay. Let us give 1. X equal to minus pi. What is fx here? 1 plus x. So 1 minus pi plus pi square. This is called fx. This is called fx. Now this side no x. So we'll substitute minus pi here. So this sine it will get 0. Once we are substituting, this will get 0 because sine n pi will get 0. So now you write here 1 plus pi square by 3 plus summation n is equal to 1 to infinity 4 minus 1 power n by n square cos n pi or minus n pi. So it will come minus 1 power n cos n pi. I already told cos minus theta is equal to cos theta. So this term will come. Now this bring this side. This bring this side 1 minus pi plus pi square minus 1. This also minus because this coming this side. So minus pi square by 3 equal to this plus no. So this equal to this bring this side a minus. So equal to what is 4 you take outside. N is equal to 1 to infinity 1 by n square. Why 1 by n square? Because minus 1 power n. Suppose n is equal to 1 1 minus 1 into minus 1 1. N is equal to 2 2 1. N is equal to 3 3 1. So whatever you will get, it will come 1 only. So okay. Now this you solve. 1 plus minus 1 cancel. So minus pi and pi square you separately find out. Pi square minus pi square by 3. What we can write here? 3 LCM. 3 pi square minus pi square. So 2 pi square by 3 minus plus 2 pi square by 3. Okay. So we got minus pi square minus pi square by 3 LCM. 3 pi square minus pi square 2 pi square by 3. Okay. So this we got. This side what is here? 4 n is equal to 1 to infinity 1 by n square. Give equations number 2. Now substitute x equal to pi in equation 1. Here substitute x equal to pi in equation 1. This equation 1 again. So what is there? This terms not there. So again pi only no 1 plus pi square, that is called fx. Now this as it is 1 plus pi square by 3, then summation n is equal to 1 to infinity 4 minus 1 power n by n square, and this also again will come n minus 1 power n because cos n pi minus 1 power n. Now solve this. 1 plus pi square minus 1 minus pi square by 3 equal to 4 you take outside, n is equal to 1 to infinity, again it will come 1 by n square only because minus 1 already told, it will come 1 only. Now this you solve. 1 get cancelled, pi plus again pi square minus pi square by 3, same thing will come 2 pi square by 3 equal to this term 4 summation n is equal to 1 to infinity 1 by n square. This gives question number 3. Now add 2 and 3, you will get the answer. This simple. See, another method is there. Check the continuity, check the discontinuity for this point to this limit to this limit. That complicated method. So just substitute in equation 1 minus pi, give the equation 2, substitute x equal to pi, give the equation 3. Now add 2 and 3. Add 2 and 3. What is 2? Minus pi plus 2 pi square by 3. This plus pi plus 2 pi square by 3. Then this side 4 and this side also 4. So 8 n is equal to 1 to infinity 1 by n square. So see here pi get cancelled. 2 pi square by 3, 2 pi square by 3. So what will come finally? Now I will rub it here. Finally what will come? See, 4 pi square by 3. 4 pi square by 3 equal to 8 summation n is equal to 1 to infinity 1 by n square. Now 8 will come here. Bring 8 here. What will happen? 2. So pi square by 6 equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus dot dot. So hence deduce the Fourier series into this form. This is the solution. So if you will solve the carefully, you can get the answers. Okay. Okay, friends, watch this video. Beginning itself, one step to second step, third step, everything watch carefully and go the full video. Then only you will understand this. Okay. And subscribe the channel. Thank you.